This video is on law of sines and cosines. We use law of sines and cosines when we're trying to solve a triangle that is not a right triangle. So we cannot use Pythagorean theorem, we cannot use special right triangles, we cannot use basic trig like SOHCAHTOA, sine, cosine, tangent. We use law of sines to be able to find the measurements of sides and angles when we do not have a right angle. The law of sines and the law of cosines are different, and they are used in different situations. Law of sines, to find missing measures in any triangle, you need, if you have the measure of two angles and the lengths of a side, so it would be angle, angle, side, or angle, side, angle. You could also have the lengths of two sides and the measure of a non-included angle, so side, side, angle. Which, again, we're not trying to do congruent triangles. We're just trying to see if if we have this information, we can use law of sines. So when we look at this, law of sines and law of cosines is based off of triangles. Law of sines, if we have this triangle here, I'm going to name the angles as big A, big B, and big C. Angles are named with the capital letters. And then we also want to name the sides. You name the side opposite the angle with the same letter. So if this is angle A, the side opposite angle A would be little a. So I'm going to use little a to name this side. If this is big B, angle B, the side opposite of big B is little b. And then, therefore, the side opposite of big C will be little c. Now I'm going to use almost a cursive C to represent little c, just so that I can distinguish between big and little c. So using this information, we can write out what the actual law of sines is. When we have two angles and the lengths of a side. So if I have these two angles, if I have A and C, and I have a side, which would be meaning that I can have, if non-included, I could have either A or C. So if I have these two angles, and if I have either one of these sides, I can use law of sines. If I have angle, side, angle, I can also use law of sines. If I have two angles, I can automatically find the third angle. So that's one of the reasons why we can use law of sines. Also, if I have two sides, let's say side C and side B, and I have an angle, which is non-included. So I would have side, side, angle. The reason we use law of sines is because we have a side and the angle and its opposite angle. If we have a side and its opposite angle, we can use law of sines. The actual equation, or the law of sines, states that sine of big A over little a is equal to sine of big B over little b, which is also equal to sine of big C over little c. It's just proportions. You only need two of them, but you can use any two. So I can use sine of A and sine of B. I can do sine of A and sine of C. I can do sine of B and sine of C. So as long as I have two of them, I can do law of sines. And again, we want to use law of sines. I'm going to make a note. We use law of sines when you have a side, one side, and its opposite angle. So again, if I have angle A and little a, then I can do law of sines. And I would just figure out, I would do sine of big A over little a, and then I could figure out either big B or little b, or big C or little c, depending on what it is I'm looking for. For law of cosines, again, we can use law of cosines if we're trying to find missing measures in any type of triangle, including non-right triangles. You would use law of cosines if you have the length of two sides and the measure of the included angle, so side angle side, or the lengths of the three sides. Law of sines is used when you have one side and an opposite angle. Law of cosines is when you don't have this. So if we have two sides, so side C and side B, and the included angle, which is here, if I have little c, I don't have big C. If I have little b, I do not have big B. I would have big A, but I do not have little a. So I do not have a side and its opposite angle, which is why I would use cosines. And if we have the three side lengths, which are A, B, and C, I don't have any of the angles, so I couldn't use law of sines. I would need to use law of cosines to be able to get one of the angles, and then I could use law of sines. So the equation for law of cosines is a squared is equal to b squared plus c squared minus 2bc times the cosine of big A. Now this is one equation. It comes from the Pythagorean theorem, but because this is not a right triangle, that's why we have extra added onto it. So whatever this is a side. If I want little a, I have to have big A. Whatever letter I have in the front is also going to be the letter in the back. My two sides I'm going to be squaring, b squared and c squared, are also what I'm going to have multiplied by 2. So if I have b squared and c squared, I'm going to have b and c inside of here with the 2. The thing is that I can rewrite this equation using any of the other sides and just rewriting the equation. So if you know one of the equations, then you can write all three of them. So for an example, if I want to find little b, I would have little b squared is equal to, so I'm missing a and c, so I have a squared plus c squared minus 2ac, because those are the same two letters, cosine of big B, because that's the same letter in the front as the back. And it all depends on what you're trying to find. So if I wanted to find little c, so I'd have little c squared is equal to, I'm missing a and b, so I would have a squared plus b squared minus 2ab times the cosine of big C. These equations are all based off of the same setup. You just change it around depending on what it is that you're trying to find. So we're going to do some examples on using law of sines and law of cosines. You just have to determine when you use law of sines and when you use law of cosines. Again, to determine that, if you have one side, a side and its opposite angle, you can go into law of sines. If you don't have the side and its opposite angle, then you have to do law of cosines, so you can find the angle, and then you can do law of sines.